What's up, everybody? This is Matt Brown with another IoT hacking video. In our video today, we are going to discuss a recent announcement by the United States government and various departments within that they are considering a ban on the Chinese IoT manufacturer TP-Link. Why are they considering this? Well, one of the reasons that's cited in this news article is the existence of security vulnerabilities in these devices. And that's what we talk about on this channel. So why should you trust me? If you're new to this channel, why should you listen to me? Well, my name is Matt Brown. I am an IoT penetration tester. My day job is looking at these devices, these routers, cameras, and finding vulnerabilities in them. I have also competed on the world stage and won competitions. This was one that I won with a good friend of mine. We teamed up and we won a HackerOne live hacking competition, the only one that ever primarily featured hardware devices. So this is right up my alley to speak about. And what are we going to do in this video? Well, what we're going to do is we're going to take this router that is made by TP-Link, the parent company. It actually goes under a different name. But we're going to take this device, we're going to have it over on our workbench, and show you how a hacker goes from physical access to one of these devices to being able to hack many of these devices out on the public internet. So before we jump into that over on the workbench, I want to discuss another hacking event that centered around IoT devices. So let's go over here to our computer and I'm going to pull up this write-up that we can find on GitHub. The links will be in the description to this write-up. Now, we cannot be 100% sure that this write-up was from the actual hacker behind the hacking team Hack. So, to give you some backstory, there is a company called Hacking Team, and they provide spyware to governments. And so, someone did not like that, right? And this individual, or allegedly the individual that wrote this write-up on how they hacked this company, decided to take matters into their own hands and to attempt to break into this company's networks and steal data. So in this write-up, we're not going to read the whole thing. I definitely encourage you to, because you get a lot of tidbits out of it. But in the introduction, he discusses, he or she, I'm just going to say he discusses his political motivations for why he believes this is a valid target and this is a moral target. We're not going to discuss that in this video. We encourage you on this channel to only hack things that you physically own. And so we're going to scroll past that. And then he talks about how to stay hidden as an attacker. Again, that's out of the scope of our video today. And then he discusses how he technically got into this network, the technical means that he got into this network. And he did his initial reconnaissance of this company's network, and he basically narrowed it down to 3 ways that he could get into this company. And so here we see that he needed either a 0-day in Joomla, that's a popular blogging like content management system, a 0-day in Postfix, a mail system, probably pretty hardened, or this hacker needed to look for a 0-day exploit in an embedded device. And so in this write-up, the hacker describes how that is the target they picked, and they acquired one of the devices that was on said network. They didn't have physical access, obviously, to the real device that is on his intended target's network, but he got access to a similar one and took it apart, reverse engineered it, and in a little bit found a 0-day, a remotely exploitable 0-day in one of these IoT devices. And from there, this individual used that access to exploiting the IoT device that was on the edge of his target's network to then pivot into the network and to perform the actual goals that he had of accessing sensitive data inside their networks and exfiltrating it. And of course, he leaked that to the world, and then he achieved his political goals, right? But we are not encouraging that on this channel, but we are going to discuss how hackers go from having an IoT device to reverse engineering it to developing an exploit, all in this video, and to finding a real one of these devices on the internet that is exploitable. We won't actually exploit it, but we will show you that they do exist. So let's go over to the workbench and let's talk about this. So here we can see that I've already taken the guts out of this device, and we have it sitting here on the desk. And so there are two things that a security researcher is going to look for when they have a device like this in front of them. There are some others, but we're going to talk about two today. One is UART, and the other is the flash storage on the device. So we're actually going to take an even closer look at this device underneath our microscope. And I'm going to show you how we're looking around this board, and I see something like this on the circuit board. So this is labeled J3. J usually stands for jumper on one of these boards. And I will say that these pins were not on my board soldered into here. I added these, but this clearly looked, these 4 pins looked like a UART interface. What is a UART interface? Well, that's a good question. So a UART interface is a serial interface to a embedded system. In this case, it's going to be an embedded Linux system, and it's going to give us that kind of console access to the command line of the system. Now, it may be password protected, but we will work our way around that when we get to it. So the first thing we got to do, though, is we want to get our multimeter ready to figure out what these pins are. So I've got my multimeter here, and I'm going to put it into continuity mode. And then I'm going to grab my probes, and then we're going to probe around here. If you followed my video series in the past, we are going to go over some ground that we've already covered for the new folks in this video. So I have it ready to go, and the first pin I want to find is ground, and this is really because I want to eliminate that from contention. Okay, so here we go. We have this pin is our ground pin, and now what we're going to do is we are going to turn the device on. I'm going to flip it on over here, and then I'm going to flip to voltage mode on my multimeter. And now what we're going to do is we're going to, we can touch ground here, or we can touch it over here in the shield, and we can measure voltage. Okay, so I'm getting basically 0 volts on that pin. Okay, that pin is 3 volts. And now what I'm going to do is now, with my hand off screen, I'm going to turn the device off and on again, and now I'm going to connect my probes. Now we see, oh, you see that voltage fluctuation? That is showing that this pin is not a steady 3.3 volts, but it's actually kind of varying between 3.3 volts and 0. And so what that means is that this is most likely our transmit pin, which is going to make me guess that this one next door to it is the receive pin. And so what I'm going to do now is I'm going to take a USB to UART cable here, and I'm going to connect it up to this interface. So we already said this is ground. Now we said this pin all the way over here is our transmit pin, and so I'm going to put the receive pin of my UART cable onto that pin. Oops, that fell off. We're just going to connect this one up first, and then vice versa. So I'm putting my transmit pin, which is this orange wire, onto the receive pin of the board. So that way we have that serial data communications to and from the device. Okay, I'm going to make sure that's powered off to start with, and we're going to come over here and we're going to hop into our UART shell. And so the way we're going to do that was with a program called PicoCom. You can use Minicom, but this is basically a terminal emulator that is going to allow us to interface through that USB to UART cord that we have plugged into our device. And so we need 2 pieces of information to pass to this program. First is the baud rate. 115/200 is the most common baud rate, and when you're targeting IoT Linux devices, that's what you want to guess first. And then if you get it wrong, you can guess some of the other common baud rates. But we're going to start with that, and spoiler alert, it's going to be right. And then we need this dev TTY USB. This is the device. This is basically where that USB device gets mapped to on my Linux system. Your mileage may vary if you're using a different OS. So now I'm going to go over here and I'm going to simply power on the device, and we will see that it starts, acting. This is a Linux system that's booting up. And it'll even say, hit enter to enter the console. And it says, okay, so it's prompting me for a login, right? And it's still booting up the Linux system. So I'm going to give it a minute to boot up. But as you can see, this system is password protected. So there are sometimes some tricks where we can get into the bootloader via this UART interface, but that's not going to quite work for us today. And we want to demonstrate the other thing that hackers do when they're reverse engineering these devices to develop exploits, and that's that you always want to get your hands on the firmware. So that's what we're going to do now. Let's go back to the desk. So now what we're going to move on to is we're going to now be targeting. So instead of this UART interface, I'm going to make sure this device is powered off. And we are now going to target this flash chip right here. And let's zoom in on that with the microscope. And so here we can see that we have our CPU, we have our RAM, and right here we have our storage, our flash storage on this system. You can see it was kind of underneath this shield, which I have kind of torn off to the side so we can gain access to this chip. Now, sometimes we can perform an in-circuit firmware read where we attach like a clip or something like that to this chip, and we can perform a firmware extraction that way. I'm going to show you my preferred method, and that is a chip-off approach. So what I have is I have a hot air Rework, I have a hot air gun, and we're going to point that at our chip. And that is going to melt the solder on all 8 of those connectors. And then we should be able to pull this chip off. And there we go, it is off. That was pretty simple. So I'm gonna bring this chip front and center here. So here we go. This little chip is what stores all the software on that embedded Linux device. I'm gonna turn off my multimeter. We don't need that anymore. All right, so what we're gonna do here, normally I would clean this chip up a little bit, but it looks good. I can see in the microscope that there's no solder bridging in between any of the pins, so that looks good to go. And so what I'm gonna do now is I'm gonna prep it to go into this reader for these flash chips, this flash reader. And so let's get this in focus. So the way that this reader wants me to do this is, see that little dot there on the chip? That is a pin 1 indicator. And we are going to simply press down and press up. And it wants the chip to be down at the bottom, but pin 1 facing up. And I'm a little bit of a perfectionist with this, even though that is not necessary at all. Okay. Yeah, I'm actually just making it worse. All right, there we go. Nice and locked in and connected. And now let's go back to the desk, because so then this little socket gets placed into our universal programmer. This is the XGECU T56 universal programmer. And so we're going to drop that in again all the way at the bottom. If we get it to line up there, there we go. We have the chip, pin 1 facing up, all the way down, and then we're going to lock that in place. And now we're going to go back over here. So now let's go ahead and dump our firmware. So this tool has a proprietary Windows program that you can use to dump the firmware. It has a GUI, everything like that. I can run that under Linux using Wine, but there is a really cool project called Minipro, and they have recently implemented the reading of these kind of chips on this reader with open source software. So very excited about that. So what we're going to do is we're going to first run Minipro-L. So we're going to like search for the number on this chip. So if you saw there under the microscope, there was a little identifier that was written on the chip, and what that said is GD25Q64E. That's basically the model number of this chip. Now, when we search for that in the database, we actually see that there's a number of them that are like that, and you can see that they're the same serial number and then at dot and then a different identifier. This is the type of package. It's the form factor. It is the physical dimensions and layout of the chip. And so really any of these 8-pin are going to be the same, but my chip today is this SOP8 chip. And so what we're going to do is we're going to run Minipro -P, and then we're going to paste in that full string there. And then we're going to say -R to read the firmware out, and then we're just going to call it firmware.bin. And there we go. It says it's reading our code, and that is awesome. So we're going to wait for that to finish. Awesome. Now what we're going to do is we're going to run binwalk -E to extract the firmware. It also gave us this EEPROM thing. Let's just get rid of that because that's all blank. We don't need that. Let's run binwalk -E, and it's going to perform the extraction, and it's going to dump all of the extracted file systems and the things that it could find inside that firmware image in this folder called extractions. So let's go in here, and it found 4 different file systems. So what we can do is we can just, we can start to look through the file systems on this device, which is really cool. Now, before I get too involved here, I actually want to get this chip back on the board and get this device functioning again. So what we're going to do is we're going to come here and we're going to get ready to check the UART interface, because that'll be our proof of life that we have soldered the chip back on correctly. So over here, we're going to pull the microscope over. We're going to find our spot on the board. And now I'm going to take the chip out of the reader. And we're just going to line this back up. Because this is one of these 8-pin chips, I can actually get away. Let me get that back in focus. I can actually get away with not putting down any fresh solder. I am going to throw down just a little bit of flux. So this is going to help all the solder and stuff go where it should. There we go. That looks great. And then I'm going to get this in basically the right spot, because the cool thing about all this solder with the flux is when it's all heated up, it'll just kind of naturally go where it needs to go. All right, so we're going to throw hot air at the chip. Here we go. Oh yeah, you see it start to move a little bit. There you go. See, it's kind of just floating into the correct place. There we go. Awesome. That looks great. We're going to let that cool off just a little bit. All right. That looks awesome. I'm just going to take a little bit of isopropyl alcohol and clean up. Okay, that's starting to boil off there. A little too soon. All right, so there we go. We got our chip back on the board. Let's go ahead and test this UART interface. I'm going to power it on. And confirmed. We have confirmed that we've soldered the chip back on, and it's good to go. So now I can take these stupid gloves off. I don't suggest soldering and then, eating a bunch of food or drinking stuff when you're doing this work. So again, we're stuck at this login, right? We don't have the login, but we have the firmware, right? So what we can do is we can just, grep through here for maybe a password file, right? Okay, cool. There's a couple of these files here. Okay, that doesn't exist, and I think that's because it's a symlink. Let's try this password.back. Maybe something interesting is there. Oh, cool. All right, so here we can see a password hash, okay? So we could bust out Hashcat and we could crack this password, or we could just Google it, which turns out to be the best way to deal with this because somebody else has already cracked this password. All right, that's not gonna work. There we go. We can go over here and we can search for it, and we can see that somebody has already cracked this password, and it's, so username admin, password is 1234. I'm not kidding. That's how easy it is on this to find the root password for this, the administrative password for this system. So we go over here, admin 1234. Okay, awesome. If you watch my channel, I've actually already done this on this device. So you can go back and watch those other videos for a lot more detail of how I got to this point. But what I want to do now is talk about how to take this to the next level and find an exploit that I can find over the network on this device, and then maybe find devices that have that same service on the public internet. So the first step is going to be to connect this device up. So what I have here is, over on the desk, is I have an Ethernet cord plugged into the LAN port on this device. The WAN, the wide area network port on this device, is the 4G signal, and I live in the Bat Cave down here, and so I don't have cell signal down here, and that's just not going to happen. So what we're going to do is we're going to just look for any services that are on the LAN side, and then we're going to try to find any of those same services out on the public internet. So what we need to do is, let's go over here and just get a shell. And I'm going to, okay, so this interface right here is a USB to Ethernet card. It's basically an extra network connection that I have on my computer here. And what I'm going to do is I'm going to use this, and I'm going to DHCP myself an IP address from the router on the LAN interface. So the first thing I'm going to do is I'm going to not lose my DNS, because that is probably going to, like, when I run DH client, it's going to try to like stomp on my DNS server. So I'm basically going to make it. So I'm going to set the immutable bit on that. It's a little trick. So now this file, even root can't go right to this file. So now what we're going to do is we're going to run DH client. We're going to run a DHCP client on that interface and ask the router for an IP address. Looks like we've got one. So let's run ifconfig on that interface again, and it has given us the IP address of 192.168.1.100, and we can run, you know, netstat, and we can grep for 192.168. And we can see that, okay, well, we can assume we know what the gateway is. I'm not gonna dox myself right now, but 192.168.1.1 is gonna be the router for this device. So let's go ahead and run nmap on that. Let's just run a port scan on the device. Fascinating. There's telnet open. That's a great idea, right? And we have a web server, what's probably a web server on port 80, and then we have something on 1900 UPnP, which is also pretty exploitable on a lot of IoT devices. But today, let's look at telnet, and then we're going to look at the web, because that's really interesting. So telnet, we're just going to write telnet, our device. It's asked us for the password. 1234. We're in. Okay, now this is not a full-blown root shell, remote shell, because you can see this is like a specialized command line interface that is it's not going to give us, it's going to let us configure a lot of stuff, right? You don't want to expose this to an attacker, but it's not a full shell environment, right? It's not. It gives you some administrative capabilities, absolutely. So this is bad. And what's even worse is the first time I set this up, it actually prompts you to set the password without asking you for the password first, the first time you ever set it up. So that's not a good thing. But let's talk about that other interface, that web interface. So right here, we can see that we can actually navigate to this web interface, and it's asking us for a password. Now, strictly speaking, on a Linux system that has a shell and a web application, those two things do not have to keep credentials in sync, right? Like there could be an administrative login to the web application that doesn't work on the shell, and vice versa. But I mean, come on. Do you think that it's really going to do that? All right, password 1234, and we're in. Okay, cool. So we can use that same set of default credentials to bust into this web interface. Well, this web interface is only local. It's like you have to be on the network in order to exploit it. So this is not a big deal, right? But what if we could find this same web interface out in the wild, right? Well, so what I would do if I want to do that, I'm actually going to go back to the login page here. Yes, I'm sure that I want to log out. Okay, and then I'm going to go look at the source, because what I want to find is I want to find like a string that I can search for in a public data set. And so actually, like here we can see the title is set to, you know, MB. This is like the, you know, here we go. Here we go. Where is it? Yeah, dash 4G. Anyway, it's hard to see down there. But yeah, so MB110-4G. That is the identifier of this device, and it appears in the login page on this web server. That's really important because we can now scan the internet for a web page that has that string in it, and then we can make a logical assumption that, oh, hey, that device probably is running all the same software as the one that I have my hands on it, right? I can go from having specific knowledge about an IoT device that I have physical possession of to inferring a remotely exploitable vulnerability that exists out on the internet. So there's this cool little service called Census, and they do that all the time. They scan the entire internet and they index all this stuff, right? So I was able to perform this search on that string, and it came back with, you know, it came back with quite a few results here. So we can click through these, and you can even see what services are available here. Now, some of these are going to be false positives, right? That's always going to happen. But there's one here that is very interesting. So here, here we can go. We can see one that is located in Taiwan, one of these devices, and right here in the CA of the certificate. So this one is running, you know, HTTPS. It's an encrypted web server, as opposed to, I was just using port 80, the cleartext HTTP one, but same thing. Here we can see that it actually found that in the certificate name. So I feel like I'd actually be able to find more devices if I knew how to craft this search better. But this is a really fast search here. And you can see that, yeah, okay, so right here, this service might have that same web interface. Well, now, if I try to go to this live, it takes forever, but I did find it. It's there. It's the same login page. I'm not going to log in with the default credentials, but this device is publicly exposed on the internet with the crappy software that we saw. Within this length of this video, we obtained the hard-coded default root password, the default admin password on this device, and it works on the web interface, and we can find these web interfaces on the public internet. This is why attackers love IoT devices. Usually they're not the target themselves. Usually they don't care about the data that's actually on this device. They care about these devices for two reasons. And so we see these actually in these two stories, right? We bring it all back. So in the TP-Link case, the attackers who are performing this, the attack using these devices were using these as hop points, right? Places to have their attacks come from so they could be distributed, right? Because if you come from one place or you come from a known location, you can start blocking by IP addresses. But if you have lots of IoT devices, kind of like a botnet, then it's a lot harder to block, right? And so that's one reason an attacker may want to exploit a bunch of these IoT devices. And the other reason, which again, we talked about in the hacking team write-up, this might be on your edge, especially a router device, right? If you have a publicly facing side of it, but it's also the router that connects to all of your sensitive devices on your local network, that is the way for a remote attacker to gain access to your network. So for those two reasons, we showed in this video how easy it is for an attacker to rip open one of these IoT devices, find vulnerabilities, and exploit them. Let me know in the comments what you think about this ban, because I'll be honest, there's lots of other device manufacturers that we could have done this same thing for in the IoT space. It's not just TP-Link or MurkySys, all its subsidiaries, right? There are lots of companies that have these bad security practices. So let me know in the comments what you think about this. Do you think the United States should ban this company? Do you think they shouldn't? Do you think they should ban a bunch of devices from the US market? Let me know what you think. Please subscribe to this channel if this is your first time here. I do lots of videos like this where I rip open stuff on a desk and I show the real world impacts of IoT vulnerabilities, and we have a lot of fun. Thank you. Have a good day.